Hello. Today I'll show you how to design your own satellite orbit using traditional orbital elements. These 6 parameters define orbits in inertial space relative to the ECI coordinate system. When an epoch is associated with these elements, they also define how that orbit relates to Earth's current rotation angle. These are essentially the same as state vectors, but have an older format that allows you to more easily visualize the orbit when simulation software is not available. Start by clicking on the New button to ensure that all other orbits are removed. Now click on the Add Satellite button to see the Set Initial Parameters dialog. This time, choose the Orbital Elements option. Note that in the upper left corner, you can choose between Earth and Moon as the body you want to define an orbit around. We'll demonstrate lunar orbits in a separate video. You can also see the epoch. We'll keep this the same as the simulation start time, which is the default. Let's create an elliptical orbit with semimajor axis equal to 9 million meters and eccentricity equal to 0.1. Don't forget to use the Tab key between text box entries. This is a near-Earth orbit that is not exactly circular. A circular orbit would have an eccentricity equal to 0. Now, give this orbit an inclination relative to the equatorial plane equal to 20 degrees. Next, set all 3 of the following elements equal to 0. This places the satellite and perigee over the equator when the simulation starts. Note that the orbital period is calculated to be almost 2 hours and 22 minutes. Now, click on the Set Parameter and Recalculate Orbit button. When the current dialog closes, the new orbit is shown. However, it may not be complete. Change the simulation time span to 2 hours and 22 minutes so you can see one complete orbit. Then press the Tab key and recalculate the orbit. Note that the satellite is at perigee and over the equator as we expected. Verify this by clicking on the Equatorial button in the Camera Group box. Next, change the camera settings so that viewing from and orientation are set to not controlled. Also, verify that the looking at and rotation point are both set to Earth. Rotate the camera so the orbital plane is approximately in the plane of your computer screen. This occurs when the orbit appears to have the most area inside the orbit. Now click on the first simulation button that shows 2 red dots on an elliptical orbit, one for apogee and one for perigee. This places the satellite at the next apogee or perigee, whichever comes first. Click on it again to find the next one. Next, return to the beginning of the simulation. Then, click on the next simulation button to find the 2 nodes where the orbit crosses the equatorial plane. There is one for the ascending node and one for descending node. These 2 are the same as the apogee and perigee for this example, but that will often not be the case. Run the simulation for a few seconds and practice using the simulation buttons. The symbols should be recognizable from the old days of tape players. Also, practice rotating the camera around Earth and zooming in and out. If you want to save your orbit project, click on the Save As button and then choose a name for your project. Thank you for watching this video. We hope you enjoyed it. If you did, please give it a like and consider subscribing to the channel. We will be producing new content in the future, so it is also worth hitting the notification bell. We would love your feedback, so leave a comment in the comment section. Until the next time. Goodbye.